This is Richard Chernock for Systems Academy. This is part 2 of acceleration and one-dimensional motion. We're calling it one-dimensional because we're just using scalar values here. We're not using velocity in terms of a vector or acceleration as a vector, but I'm showing that information here in reference to how Sal Khan shows it in the Khan Academy videos under physics. If you look under physics one-dimensional motion videos, he shows you the math there. And also this is part 2 because we're going to show you some different values, and we're going to compare it to the quadratic differential equations. So you'll find another video here in Systems Academy called Part 3, Quadratic Differential Equations. And you'll notice here that we have two stocks. The yellow boxes are the levels or stocks. And then we have two flows. And this is the same basic model that I just showed you in acceleration in a one-dimensional motion. So the two flows are accelerating and velocity, and the two levels are velocity and displacement. So let's just look at these two, and we'll change the data here so that we get the same values here. The initial value here is 10 for y, and the initial value down here is 5. Let's see, for this we're going to make the initial value is b. We're going to make that 5 instead of 10, instead of 30 I mean. And for our first run here we're going to make this 0, so that we start with the same values as we did in the other. Let's see, this flow is going out, so this is a decay instead of a growth for this flow. So this is going to be interesting. We'll see what this graph shows us here. So this is a linear graph. Well, what do you know about that? Okay, so we have the linear growth because our acceleration is 0. Now if we jump over to this one, our acceleration here is also still 0. We haven't, well, we changed it to 1 earlier because we were in the prior video. So we'll change this acceleration to 0, and we have an initial value of 5 and an initial value of 10. So let's see what this one gets us. And we get a linear growth because our acceleration rate is 0. Great. Okay, so now we're going to go back to this one, and we're going to change the acceleration to 1, and you'll see that this is reducing the value here. So we're going to get a what? We're going to get a parabola that goes down. That's because our acceleration is say it's the acceleration of gravity or something. We threw something in the air off of a wall, and it goes out a distance and then drops because of the acceleration of gravity. Now we used 1 for the acceleration here, but if we use the acceleration of gravity, which is 9.8, we would get a different curve that would better represent what was actually happening if we were to throw something off a wall. And you can see here that it goes out for a ways, and then gravity takes over and really starts drawing it down towards the ground. And it only went negative. Must have been off a cliff into a hole. Okay, so let's go back to this function here. Now if we put in an acceleration rate of 9.8, it's not going to make much sense because we have it going, it's a positive acceleration, so we'll see what happens here. Well, we can see that the curve goes up, so if we had something that was accelerating this wouldn't represent the physical trajectory of something, but it does represent the displacement of an object if it were falling at 9.8 meters per second. So here we have a graph of the accelerating displacement increasing at an increasing rate. And you can see that this is a differential equation that Saul Kahn has called it physics, but he's included two stalks and two flows in a way that is the same as a differential equation, a quadratic differential equation, and you can put any number of values. Now you notice here that the flow for y prime, this flow here is negative or is flowing out. It's an outflow, so you're getting a deceleration of the level here in y prime. So that's why you can see the parabola going down. Okay, so I just wanted to use this part 2 of this talking about physics and the acceleration rate to reference you back to the video on Systems Academy about part 3, the quadratic differential equations. You can also go to Khan Academy and look at his description of differential equations, which is just right here on the left. And you can see that these are the same as what he's talking about in the physics video that I've here called Part 2, Acceleration in One-Dimensional Motion.